Welcome to the lecture series on data structures. In this lecture, we talk about Prim's algorithm. To understand the Prim's algorithm, we need basics of graph theory, in which spanning tree is required. Now, let us consider a graph G is equal to V comma E, be a graph with vertices V and edges as E. Then a spanning tree of G, T, is a subgraph such that all the vertices of the graph are present in T and no cycles are present. So any subgraph having no cycles and consisting of all the vertices of the graph is called a spanning tree. Given a graph, there may be several possibilities of constructing a spanning tree. In this example, if we have 6 edges and 4 vertices, we can have 8 possible spanning trees. Here I have given 4, but another 4 are also there. This is with respect to the ordinary graphs. Now, a special kind of graph where every edge is attached with a weight is called a weighted spanning tree. Weighted graph. Again, from the weighted graph, we can construct the spanning trees, and that is called a weighted spanning tree. Now, a special case of weighted spanning tree is a minimal spanning tree. That is, out of the possible spanning trees, we need to identify that particular spanning tree where the sum of all the edges is minimum among the such sums. So such a spanning tree is called the minimal spanning tree. Now, Prim's algorithm concentrates on finding the minimal spanning tree from the given graph. To identify the minimal spanning tree, another approach is given by Prim's algorithm, where the algorithm concentrates on vertices. Since in the minimal spanning tree every vertex has to be present, so we start with a vertex and we try to identify the least weighted edge incident on it and proceed to the next vertex. Like this, we'll try to keep on tracing all the vertices so that at every point of time we'll try to add a least weighted edge incident on it. When it comes to the algorithm, we'll start with the graph G is equal to V comma E, and we'll initiate a tree T is equal to null initially, and select any vertex as a starting vertex. Let us select U as a starting vertex here. Initialize the set S as U, singleton U, and on U there may be several edges incident on U, but we need to select the least weighted edge that is incident on U. So let us assume that UW is the least weighted edge among edges incident on U. Then add that edge to the tree and add this vertex W to S. Already U is there, now we are adding W. So from U we are tracing to W. Now when it comes to W, identify least weighted edge incident on vertices of S. Not only on W, but all the vertices that are present in S. Among them, identify the least weighted edge. That adding that should not create a cycle. Once it is found, then add it to the edge to the tree and add the new vertex that is traced to S. So this process is repeatedly done until the set S is coinciding with T. That means the entire set of vertices are traced. Let us consider the graph here consisting of A to L, vertices A to L with different weightages. Now, as per the algorithm, we initiate the vertex set. Let us choose the initial vertex as A and initialize the vertex set as S is equal to A. On A, there are 2 edges incident on that, and least weighted edge is AC. So add AC to the tree and add the vertex C to the vertex set S. Now S consists of A comma C. Now there are 2 vertices in S. Of all the edges incident on the vertices A comma C, we need to select the least weighted edge. At C, there are 2 vertices incident on that, but both of them are having weight as 3. At A, one more edge is there having weight as 2. So of them least is 2. We need to select AB as a 2, as a edge having weight as 2. Now add this B to the vertex set S and add the edge AB to the tree. Now S consists of 3 vertices A, B, C. Again, of the 3 vertices, edges incident on them, we need to select the least. Again, on B, least weighted edge is there. So add BD to the tree and add the vertex D to S. So now 4 vertices are added to S. Now again, of the edges incident on A, B, C, D now, we need to select the least weighted edge. That should not create a cycle. Now, several possibilities are there. I can add CD, but that is going to create a cycle. I need to add either DE or CE. So here I have a choice. I can do any one of them. So if I select CE, I got vertex E is added to S and CE is added to cycle T. Now, of all the edges incident on A, B, C, D, E, EL is having the least weighted edge. Now that is added to tree and L is added to S. A, B, C, D, E, L is the vertex set now. Of the remaining edges incident on these vertices, E, G is having least weightage as 1. So G is added to S and EG is added to tree. Like this. In the next step, we have to add GH having least weightage as 2 and vertex H to S. Again, I can add J least weightage as 1. J is added. HI weightage 2. I is added to S. HK least weightage as 3. That is added and is not going to create a cycle. So by this time, S consists of all the vertices of G. And it coincides, the tree also consists of all the vertices of G. Now this process stops here. Thank you for watching. If you like the video, you can share it with your friends so that majority of the students can be benefited.